Hello and welcome to level 0 of the frequency response questions. These should be fairly straightforward. Let's have a look. Here we have a capacitor connected between A and X and a resistor from X to ground. Now at very high frequencies you would expect the gain of this circuit to be 1 or 0 dB, because at very high frequencies a capacitor looks like a short circuit, just a piece of wire. So A would be connected straight to X effectively, and that would give you a gain of 1. That means that it cannot be B. The answer must be A or C. Which one it is? Well, we'll have to look at the frequency of the pole here. Remember, a pole is where the frequency response curve bends down by 20 dBs per decade. They both, A and C, start by going up by 20 dBs per decade, and they both have a pole and end up horizontal. So what frequency would we expect the pole to be? Well, 1 over 470 times 2 mu 2, which is 967, but that's radians per second. If we want that in hertz, we'd have to divide by 2 and pi, and that would be 154. So the answer is 154 hertz is where we expect this pole to be. And looking at these graphs, well, at 154 hertz, which is about there, A is about 3 dB down, which is what you would expect for a pole. C is about 20 dB down, which is way too much for a single pole. Single pole, you'd expect it to have dropped by a factor of 2 in power, which is 3 dB. So here the answer must be A. Fine. That's probably the most complicated one you can get at level 0. This one. Here we have something that is a low-pass filter. At very high frequencies, the capacitor looks like a short circuit. Effectively, we've connected our output here to ground, so we wouldn't expect to see anything at all. So we would expect the frequency response to have a very large amount of loss, or a very low gain, at high frequencies, and the only one of these curves that does that is curve C. Therefore, must be curve C. Easy. This one. At what frequency does this Bode plot have its pole? Well, at low frequencies, this has a gain of 13.6 dBs. So we would expect at the pole that the response should be 3 dB down on that. That's a factor of 2 in power. So that would be 10.6 dB. If we go down to 10.6 dB, it's about there. And at that frequency there, around about 4.5 kilohertz. That should be close enough. Right. Anything else? Oh, at what frequency? This time you just have to calculate the frequency. Well, once again, we have a capacitor and a resistor, so we can work out 1 over the value of the resistor times the value of the capacitor, 30.303 K. And again, as a frequency, that would be in radians per second. The pole is 2 pi down on that, so we would just say divided by 2 divided by pi, and that would give us the answer in hertz, or in this case kilohertz. Bang on. I think that's about all the type of problems you can get at level 0.